Hello, in this video I'm going to talk you through how to expand brackets with surds. But before I start talking about brackets, there's one skill I want to make sure we're really sure on. It comes up in the expanding brackets kind of process, but also it's one of those things that loads and loads of people get wrong. So I just want to go through a process to just guarantee that you get this right every time. The method I'm going to suggest we use is one that requires us to write a little bit down. And I do strongly encourage you to do that because I know so many students who do understand it, but they try and do it in their head. And because they've got square roots in some bits and not in others, they go wrong. So the method I'm going to show you is one that just guarantees you get everything laid out clearly, and it just helps you avoid making any little mistakes. So what I'm going to do is I'm going to multiply 3 root 2 by 4 root 2. So each of them is a little bit more complicated this time because we've got an integer and a surd in both of them. I'm going to first of all write it out as a long timesing sum. You don't have to do this bit when you do it for a question, but you can if you find it helpful. Okay, so we're just multiplying 3 by root 2 and multiplying 4 by root 2 and timesing them together. Now, multiplication is commutative. It's a really cool thing that multiplication is, and it means that you can change the order around. Doing 3 times 4 times 5 is going to always get you the same answer as 5 times 3 times 4. Or 5 times 4 times 3. It does not matter which order you multiply the numbers in. So what I'm going to do is I'm going to reorder this list so I've got the integers at the beginning and then the surd bits at the end. And I would do this if I ever had to do a multiplication with loads of surds and integers involved. So I'm going to rewrite it as 3 times 4 times root 2 times root 2. And then I'm just going to multiply the integers first. 3 times 4 is 12. And then root 2 times root 2 is root 4. Some of you will be happy going straight to 2, or you can think root 4, well, the square root of 4 is an integer itself, it's 2, so I get 12 times 2, which is 24. So I strongly encourage you to break it up, reorder it, work out each bit, and then times them together at the end. Loads of people, when they get given this question, will write 12 times root 2. They will forget that the root 2 times the root 2 becomes a 2. So that's why I encourage you to do it like that. I'm going to go through another example before I give you some questions on this to go and just check that you're happy with it. So again, I'm going to write it out as a long list. I'm going to write the integers first and then the surds afterwards. So I'm going to write 5 times 2. Those are my two integers times together. And then I'm going to times my surds. I've got a root 3 in the first one and a root 3 in the second one. 5 times 2 is 10. Root 3 times root 3 is root 9, which is just 3. So I've got to do 10 times 3, which is 30. So if you times them together, you will end up with the answer of 30. If you want to check these, you can always type that into a calculator. And even though you've got a surd in each, when they times, you end up with an integer. Okay. I'm going to put up a couple of questions for you to just have a go at to make sure that you're happy with how this works. So pause the video and have a go at these questions now, and then play it again when you've finished, and I will go through the answers and put them up as well. Okay, so here are the answers to the ones on the mini whiteboard. I'm going to do 1 and 2 step by step, and then after I've done those two step by step, I'm going to do a slightly quicker way of writing it, but I would encourage you just to keep writing it out because you will guarantee yourself the marks that way and you won't make any little errors. So for this one, I'm going to write it as 6 times 2 times root 3 times root 3. 6 times 2 is 12. Root 3 times root 3 is 3. 12 times 3 is 36. So that's the final answer for the first one. For this one, I'm going to write it as 4 times 3 times root 7 times root 7. So that's going to be 12. And then root 7 times root 7 is 7. So 12 times 7, which is 84. For the next one, we've only got a 4. If you want to, you can add a little 1 in there, because when you haven't got a number next to it, it's a 1. So we've got 4. And then root 6 times root 6 is 6. So our final answer for that one should be 24. For the next one, we've got 5 times 5. Root 10 times root 10 is 10. So we've got 25 times 10, or 250 for that one. For the next one, we've got 6 times 2. Root 5 times root 3 is root 15. Because these surds are different, when I multiply them, I don't get an integer. So the best I can do for this is 12 root 15. Sorry, that's getting a bit small on the side there. This is 4 root 2 times itself because it's being squared. So we've got 4 times 4 and a root 2 times a root 2. So that's going to come out as 16 times 2, which is 32. And for this one here again, we've got 3 times 3 times root 5 times root 5. The 3 times 3 bit's going to come out as 9. Root 5 times root 5 is 5. So that's going to come out as 45 for that one. Okay, so those are the answers to those ones. Got a bit of a challenge to think about before we move on. There's more than one right way of doing this. Pause the video and think about how you could write root 8 cubed fully simplified. There's more than one correct process to go through to do this. Okay, I'm going to go through 2 different methods and you can see that both of them get to the same answer. The first method I'm going to go for is to write a root 8 cubed as root 8 times root 8 times root 8. Root 8 times root 8 is 8 times root 8. And then root 8 can be simplified to root 4 times root 2. So I've got 8 times root 4 times root 2. I've got 8. Right, root 4 is a 2 times root 2. So I've got 16 root 2s. Okay. The other method is from here we can simplify every single one of the root 8s before we go any further. So we've got root 8 times root 8 times root 8. Now root 8 is 2 root 2 times it by itself again, times it by itself again. I'm going to put the 2's at the beginning and then the root 2's afterwards. So I get 2 times 2 times 2 times root 2 times root 2 times root 2. 2 times 2 times 2 is 8. Root 2 times root 2 is 2. And then times it by root 2. And if you put that together, hopefully you can see as well that that's going to come out as 16 root 2. So as long as you don't break maths as you go through this process, as long as you only do things that you're allowed to do, you should always find that you come up against the same final answer. Okay? Well done if you managed to get that one before I went through it. Right, so now we've seen those 2 things, we've done enough now to be able to do some expansion of brackets. So just as a little reminder, when you expand brackets, what you do for a single bracket is you take the thing on the outside and you times it by the first term inside the bracket and the second term inside the bracket. If you have a really long bracket, which is unusual, but it's not impossible, if you have a really long bracket, you would keep timesing by however many things you had going along. So 2 root 3 times 5. I'm going to write this down here. And if I were in an exam, I would always do this because people just get it wrong. You're trying to do kind of sums like this, but within the question. And if you don't write it as you go, it's so easy to make a mistake. So I would write this as 5 times 2 times root 3, which is 10 root 3. If you're happy that you can consistently get the right answer without having to do that, you don't have to do it. But I would say, particularly if you're in an exam and you're feeling the pressure, it's worth doing just to guarantee that you can confidently do it, feel like, yes, you know you've got it right, and slow yourself down a bit by writing a bit more. So now I have to do 2 root 3 times 3 root 3. So I'm going to write 2 times 3 times root 3 times root 3, which is 6 times 3. 6 times 3 is 18. So I've got 2 root 3 times 5 is 10 root 3. 2 root 3 times 3 root 3 is plus 18. So that there is my answer for that one. Okay. Now I'm going to do the next one before I leave you to do some questions on your own. So I've got to do, oh no, sorry, I'm not going to do this one yet. This is a double bracket. So now I've done an example with single brackets. I'm going to give you guys a few questions to have a look at, and then we'll talk through them in just a moment or two. Okay, so here you go. Pause the video and have a go at these ones, and I will talk it through in just a moment or two. Okay, so here are the answers. So root 6 times 2 is 2 root 6. Root 6 times minus root 2 is minus root 12. And before you leave a question, you should always check whether any of your surds can be simplified. And in this case, I can actually simplify root 12. So I've still got the 2 root 6, but root 12 is 2 root 3. Okay. If you're not confident with doing that, have another look at the first video in this series where I talk through how to simplify surds. Okay. For the next one, I'm going to do this one above just so that I've got a bit more room. 2 root 3 times 4 is 8 root 3. 2 root 3 times minus 3 root 3. 2 times minus 3 is minus 6. Root 3 times root 3 is 3. Minus 6 times 3 is minus 18. So 8 root 3 minus 18. For question number 3, I'm going to do 7 root 2 times root 5, which is 7 root 10. And then 7 root 2 times root 2. Root 2 times root 2 is 2. Times by 7 is 14. Okay, and again, you don't have to do it all in your head like I'm doing now. You can write it out to the side. I'm just doing it so that we can quickly get through them as you've already had a go at them. Okay, next one. 3 root 3 times root 3. Well, root 3 times root 3 is 3. Times that by 3 is 9. 3 root 3 times negative 8 is negative 24 root 3. Okay, and then the final one, we've got 2 root 5 times 6, which is 12 root 5, and then 2 root 5 times 3 root 5. 2 times 3 is 6. Root 5 times root 5 is 5. 6 times 5 is 30. So that's the answer to the final one. I'm now going to go on and talk about double brackets, which are very, very similar. And for this, you just need to follow the process you learned for multiplying double brackets together. So hopefully you are familiar with the process for double brackets. Everything in this bracket has to get times by everything in this bracket. A lot of people like to do this systematically. So they'll do the 7 times the 2, then the 7 times the 2 root 3. Then they'll look at the next bit and do the root 3 times the 2 and the root 3 times the 2 root 3. Okay, so I'm going to do that. And then I'll just mention another way of laying it out that I know some people prefer. 7 times 2 is 14. 7 times 2 root 3 is 14 root 3. Root 3 times 2 is 2 root 3. You'll notice that I'm tending to put the root after the integer. I always do that because it's easy to simplify afterwards, and it's the way that we standardly write it in the notation. Next up, root 3 times 2 root 3. So I've got 2 times the 3, which is 6. Now, when you do this with surds, what you will pretty much always find is the first and the last bit, if you do it in this order, will be integers that can be simplified. So 14 and 6 make us 20. And then the two middle bits, if the surds are the same, can also be simplified. So you've got your 14 root 3 and your extra 2 root 3. 14 root 3s plus another 2 root 3s gets me to 16 root 3s. So unlike in algebra, where you might have, for example, x plus 4 times x minus 5, where you end up with 3 bits when you simplify, when you do it with surds, you often only get an integer bit and a surd bit. Not always, so you have to think every single time, but you often do. Okay. I'm now going to give you some questions, but before I mentioned that I would show you an alternative way of laying this out. So I'm just going to show you the alternative because some people prefer that instead. So what you can do instead is you can draw a grid. Now, the grid method is something that actually is really useful to know about for higher level maths anyway, because I teach dividing polynomials in A-level with this method. So even if you don't use it, it's worth following to make sure you understand. The first bracket we put along the top. So I put the 7 here and the plus root 3. If you learnt grid method of multiplication, it's basically that. For this one here, I'm going to write the 2 there and then the 2 root 3. So the first bracket's going along the top, the second bracket's going down the side, and then all you do is you multiply inside the boxes. So 2 times 7 is the 14, 2 times root 3 is 2 root 3, 7 times 2 root 3 is 14 root 3, and 2 root 3 times root 3 is 6. The 4 bits you get out will be exactly the same as if you just list them, because it's the same process that you're doing. But some people like this because when you do it with surds, you'll find that these diagonals simplify together and these diagonals simplify together. So if you're someone who likes a visual way of doing it, or you're used to using the grid method for expansion, then you can stick with that if you want to instead. Okay. So have a go now at these 4 questions with double brackets using whichever of those 2 methods you personally prefer, and pause the video and then I will go through it in just a moment. Okay, so here are the answers to these double brackets. 2 times 5 is 10. 2 times root 3 is 2 root 3. Root 3 times 5 is 5 root 3. And root 3 times root 3 is 3. That simplifies to 13 plus 7 root 3. Next one, 8 times 4 is 32. 8 times root 6 is 8 root 6. Minus root 6 times 4 is negative 4 root 6. And minus root 6 times root 6 is minus 6. Always make sure you look out for the minus, okay? That minus is attached to that root 6. So whenever you're multiplying the root 6 bit, you need to be thinking about that minus. If I now put it together, 32 take away 6 is 26, and then 8 root 6 take 4 root 6 is just positive 4 root 6. Next one, 9 times 6 is 54. 9 times minus 3 root 5 is minus 27 root 5. 2 root 5 times 6 is 12 root 5. And then 2 root 5 times minus 3 root 5. This is the point at which it's good to write it for yourself. But I've got 2 times minus 3, which is minus 6. Root 5 times root 5, which is 5. Minus 6 times 5 is minus 30. This is going to simplify down to 24. And then minus 27 plus 12 is going to be minus 15 root 5. So 24 minus 15 root 5 for that one. Right, for the last one, so I'm just going to rub out the ones above to give us a bit more space. Whenever you see a bracket squared, that's just a double bracket in disguise. So 3 plus 2 root 7 squared is just 3 plus 2 root 7 times 3 plus 2 root 7. Okay, so I'm now going to go through the same process for that one. So I'm just going to take the question away now. I've written it out above. So 3 times 3 is 9. 3 times 2 root 7 is 6 root 7. 2 root 7 times 3 is 6 root 7. 2 root 7 times 2 root 7 is 2 times 2 times root 7 times root 7. 2 times 2 is 4. Root 7 times root 7 is 7. 4 times 7 is 28. Again, it's that last bit where you've got surds in both that you can write out step by step and work through, just like you would for the ones that we did at the very beginning, because that's all it is, just coming up within the question. Now I'm going to simplify it. The 28 and the 9 make 37. 6 root 7 and 6 root 7 makes me 12 root 7. Okay, so that's the answer for that one. So this question can come up at GCSE just standalone. It can also come up with geometry, and it can come up with something called difference of two squares, because that's a very useful thing for other things. I'm going to do difference of two squares first, and then I'm going to show you guys a couple where we've got some geometry coming in, because it's not too bad. There's no extra skills needed. It's just don't be afraid of seeing it within a geometry question. I will be doing more on difference of two squares in a couple of lessons' time, because this is required to be utilised within other parts of the surds topic. But for now, you have the skills that you need to be able to expand these. You'll notice that when I've made these brackets up, I've made the brackets exactly the same as each other, except for one has a plus and one has a minus in the middle. They are called the complements of each other. The complement of 5 plus root 2 is 5 minus root 2. Okay, it's spelt complement with 2 E's in the middle, so it's different from a complement as in someone saying something nice. Have a go at expanding these out, and I'll go through the answers in just a moment. Okay, so here are the answers for the difference of two squares ones. I've written out the process for each one. So for the first one, these are the bits that we get out at first, and then I'm going to do some simplifying. So 25 minus 2 gets me 23. And then I've got minus 5 root 2 and plus 5 root 2, and they actually cancel out. So I'm left with just 23. For the next one, I've got 64 minus 3, which is 61. And then my minus 8 root 3 and my plus 8 root 3 in the middle cancel each other out. So I've just got my 61 as the answer. And then for the final one, I've got 7 take away 2, which is 5. My minus root 14 and my plus root 14 cancel each other out. So 5 is the answer. So with all of these, where we have difference of two squares with surds in, the answer comes out as an integer. Really, really nice and simple. The reason that happens is because of these two middle bits cancelling out, because one's a plus and one's a minus, but other than that, they're the same as each other. The quick way to do this, because we know that this is going to happen, is actually to just do the 5 squared minus the root 2 squared, because the 5 squared is the first bit and the root 2 squared is the second bit. So you could do, for example, this one, 8 squared is 64, root 3 squared is 3, 64 minus 3 is 61. So people who are really confident with this can sometimes get into the habit of doing these in their head without having to write anything down. So for example, let's say I had 9 plus root 2, 9 minus root 2. I notice it's difference of two squares because the brackets are the same except for a plus and a minus, so I've got complements. So if I wanted to do this quickly, I could do 9 squared, which is 81, root 2 squared, which is 2, and just do a subtraction. 81 take away 2 is 79. So if I expanded and simplified that, I would end up with 79 as an answer. So that's the really, really quick way of doing it.